Where's the doodad? It is.
안녕하십니까? 미래의 Technologies, John Wainwright, CTO 이라고 합니다. 감사합니다. 제 한국어가 부족해서 영어로 말씀드리겠습니다. 죄송합니다. We'll provide, you want to mention that we'll provide a translation next week.
Okay.
Okay?
Yeah.
Thank you. So today I'm going to talk about the future, the current available app development platforms for generative AI applications and their prospective futures in the context of HyperFlow AI. Now, we've all witnessed the amazing growth of generative AI capabilities over the past few short years, and can see these advances are accelerating rapidly. Businesses and institutions everywhere are realizing that leveraging AI is crucial. But there are significant challenges. Developers with expertise in this field are scarce, and even when you get them, development times can be very long. This explosive growth of AI services, all with different APIs and integration schemes, has contributed to these long development times. And so, development platforms for AI apps are emerging to address the expertise shortages and long development times. Let's first review the evolution of these platforms to help us see where things are heading. First, of course, there has been and will always be pure code. But this approach is certainly the one requiring the deepest expertise and results in the longest development times. There are coding libraries that help with this, starting with low-level API libraries like TensorFlow and PyTorch, but these require the greatest skills. And there are orchestration libraries like LangChain and LangGraph, which provide significant help, but these libraries address only a small portion of the AI app development lifecycle, the core interaction with AI services, and not a fully deployable app. At the other end of the spectrum are simple extensions to chatbot services like ChatGPT plugins. These provide functional extensions to interactive chatbots, but are limited to chat-based applications, and even then, bound to specific services like their chatbot UIs. Some of the first large-scale integration of generative AI services were in existing chat-based customer service platforms like Zendesk and Zenbird, grafting LLM interaction into their decision tree-based tools. They let you replace nodes in the Q&A style decision tree with LLM chatbots for more natural language interactions. But this was in the specific context of customer support. And then the existing general purpose no-code visual workflow tools like Zapier and N8N began adding AI-related nodes to their workflow development tools. These are much more general and serviceable than the extended decision tree platforms, but since they are not natively AI, they can suffer from mismatches to the demands of AI workflows and often lack important AI infrastructure, such as integrated asset stores or production AI DevOps tools. Then there appeared the first generation AI-specific no-code development platforms like Stack AI and Flowise. These visual workflow tools certainly address the impedance mismatch I mentioned that attend grafting AI into the general purpose no-code workflow tools. they do have some limitations being first generation. In general, they do not provide for iterative or adaptive flows, which are essential for agentic multi-LLM workflows, where LLMs themselves will guide and adapt the flow. And they also either support data flow in their visual flows or process flow, but not both. And you need to be able to specify both in the visual language that you're using. And having, as they did, their genesis in the early days of generative AI, when the number of alternative services was small, they have a service-locked workflow design such that every time you wished to change a service provider, say from OpenAI to Anthropic or Gemini, you had to recode the workflow, making it very difficult to do exploratory development or to make your flows adaptive across different service providers. Then the next-gen AI platforms, of which HyperFlow is a leading example for all of these essential requirements. And in HyperFlow's case, they're built from the ground up for generative AI. And they use the most advanced state-of-the-art software engineering principles. The things that I learned many times at my experience at Apple and IBM and Autodesk and so forth, bring my expertise in deep language design to the HyperFlow internal architecture. These next-gen platforms naturally support directed cyclic flows so that you can set up complex iterative flows and adaptive flows. And the data flows between each step can be directly expressed both as process flows, so you can control very carefully the sequencing within a workflow, as well as the kinds of data that flows between these steps. Both crucial parts of an application that you want to be able to express in the visual flow language of the tool. Here's an example. You can see here the purple lines are the process flow lines. The blue lines are the data flow lines. And you can see I've set up a cycle here. This is a looping development tool that explores different services in a loop and shows me the result over an instance. I'm doing some explorations in this loop across a number of different service providers. As mentioned, the underlying technology uses state-of-the-art software engineering principles, such as strongly typed, fully first-class data flows, built-in support for rich media, including audio, video, and images, so that fully multimodal workflows can be constructed very easily. And the presence of a crucial abstraction layer between the nodes in the workflow and the expanding set of services and providers that are now appearing can be accounted for and handled by a design of what we call a supernode. These are abstract nodes in a workflow that can be connected to any number of services, including those that don't yet exist, very easily. And it makes it possible to build generic flows that don't need to be changed to accommodate new services. They become crucial IP of an enterprise, these generic workflows. Here's an example. This is a simple, consistent flow that can be used for all kinds of RAG knowledge base building tasks. Importing content, potentially transforming it, breaking it up into knowledge segments, constructing indexes of various kinds for that content, and storing it in a knowledge database. This flow, unchanged, can be used with many, many different sources of data, web, files, API, databases. Different kinds of transforms can be applied. Different kinds of segmenting can be applied. We have something like 10 or 15 different transformation services, perhaps more than that in the way of content segmentation. And we have access to 3 or 4 different databases, knowledge databases, both vector databases and index databases. And they're all accommodated by this single flow, which does not change. They will also feature multiple execution engines. The idea here is that you want, for different purposes, engines tuned in different ways. So for example, we have 2 engines in our system, 2 execution engines for flow graphs. One that's tuned for development purposes, to help debugging and to visualize what's happening as you're building the thing. And another one that's tuned for production deployment. So it's much more efficient and tuned for special control that you need for production development. And they will also have integrated components that are essential for the entire life cycle of developing generative AI applications, like an integrated asset store where you can control and view and manage all of your knowledge assets. They'll have built-in chatbots that are very easy to deploy, and they'll include DevOps tools that will help you manage and deploy your production generative AI applications. Here, for example, is a display of the asset manager that's built into HyperFlow, allowing you to see all of the content that's come in and that's been generated, manage it, export it, import it, generally take care of all of your assets. Here's a chatbot styling tool that's built into HyperFlow. So if you wish to deploy a chatbot, you can use our built-in embeddable chatbots and apply styles within this styling editor. This again is built into HyperFlow, not commonly built into some of these other tools that are not generative AI at the outset. And here we have a production deployment management system that allows us to control which production apps are active, which are in maintenance, how well they're running, and generally to control their deployment fully. All of these need to be in a next generation, fully capable generative AI app development platform. So all of the above next-gen capabilities are available now in platforms like HyperFlow AI. And because of their advanced technical architecture, they readily support the development of future advancements. Things like parallel processing flows, where you might have multiple LLMs all running concurrently at the same time, perhaps exploring different solution paths, or running at the same time as the main LLM, doing guardrail checks on the input and on the forming output of the LLM. These are crucial performance improvements that are capable of being built into a system like HyperFlow AI. And we're certain to continue to need hybrid solutions, those solutions in which a lot of the application is developed using no-code techniques, but certain, say, business critical rules must be encoded in hard code. We can't leave that up to the creativity of these LLMs just yet. So it's necessary to be able to build these hybrid systems that have got both flow code, no-code flows in them, and small pieces of code that implement these business critical components. And HyperFlow AI has a very, very sophisticated coding capability built into the flow system. Another thing that LLMs lack at the moment is long-term memory. Almost none of the LLMs at the moment know what's going on from one conversation to the next. The conversation history has to be sent up to the LLMs on every occasion. And what's crucial is to provide not just long-term memory, but per user long-term memory. So if you have a number of users that you want to accommodate and support with your generative AI applications, you would like the system to have a memory that's associated with each individual user. And so HyperFlow AI has just added per user long-term memory, and in a way that's independent of the service provider. So this same long-term memory can be shared between OpenAI, between Anthropic, Google, and any open source models that you have in your system as well. And finally, these systems allow us to explore. All right, just let me make sure that I'm going to say the right things here. Yes, and finally, platforms like HyperFlow AI make it possible to explore a new world of vertically oriented domain-specific languages, or DSLs. These are designed to make it very easy for LLMs to generate high-level complex scripts in some particular domain, allowing them essentially to perform complex tasks by building scripts in these DSLs. You are already aware probably that LLMs are being taught to code, to write code. And this so-called vibe coding, it's a very, very big thing. The idea here is to build special purpose languages, very compact, easy to learn languages for LLMs in specific domains so that they can provide all kinds of complex tasks, perform all kinds of complex tasks in a way that they cannot at the moment. And as an example of that, we've just recently added a new DSL, a new experimental domain-specific language in the area of media and video processing. So this allows LLMs to construct scripts that do image processing and video editing. And this flow that you see here, or a portion of it, has 5 LLMs that take some basic prompts and generate a script for a multi-scene storyboard video. They generate prompts for the video. We're using one of the Gemini video generator LLMs to generate clips of 5 to 10 seconds long. And this particular fellow here, he's been taught to generate one of these scripts. He's an actual video editor. So the LLM is generating edit commands to build a video, to plug together videos that have been generated by other LLMs and produce a final video. So I think I have, here's an example of one of these DSLs. This thing here says, put a title on the first video clip. Here's another title. And down here it says, join the video clips together in a long sequence with transitions between them, and then save that out as a finished video. And we wind up with a video like this. Let's see if we can get it to play. So this was a three scene video. I asked it to generate just from a simple prompt, windsurfing on Sydney Harbour. It made up the storyline. It generated prompts for the videos and produced an edit script to produce the final video that you see here. You can see the LLMs are not quite that good at the moment. This is not really windsurfing, but they're getting better. And we're planning to provide these kinds of domain-specific DSLs in HyperFlow, more of these in the future. Thank you very much.